Today I want to take you through a couple examples of even and odd functions, and then an example of a function that doesn't fit into either category. An even function has symmetry about the y-axis. So what does this mean? You've probably talked about symmetry in the past. Butterflies have symmetry. When you fold them in half, everything matches up on the right side to the left side. A lot of times in art class, you talk about symmetry of faces and things like that. What makes this function symmetry special is that it does have to have symmetry about the y-axis, which means the only place that you're allowed to fold the graph is on the y-axis. And when you do that, if every point on the right has a mirror image point on the left, then it does have even function symmetry. Sometimes when you are testing symmetry, you don't have the graph provided, you only have the equation. And so there is an algebraic way to test symmetry. And what we do is we make a replacement. Everywhere that we see an x in the function, we replace it with negative x. Make sure that when you're doing this replacement, you use parentheses in each of these locations. And then we simplify, clean up this new function. And what we are looking for is, if this function is even, then my new function will end up being exactly the same as my original function. So one of the things you want to keep in mind as you are cleaning this up is that anytime you raise something to an even power, it is going to make that something positive. So when I am squaring negative x, I actually am getting positive x squared. So the answer to this first term is negative 3x squared. And I didn't have to do anything to the second term, so I'll just write that down. And now I will compare this new function to my original function, and it is identical, which means this particular function is even. An odd function has symmetry about the origin. And so a lot of times the way I will describe this to people is to tell them to think about a pinwheel. If you were to take a push pin and put it into the origin right here, you actually could spin this graph around 180 degrees and it should land directly on top of itself. Another way that you can test this is you can draw a diagonal, and if I was to draw a diagonal, then this point would match up perfectly with this point. And what you would notice is that it would be its exact opposites. If both of these coordinates were positive, it would be the same exact number, but both of these would be negative. Just like we did in the previous example, if we don't have a graph available to look at, we actually can test out algebraically to see if this is an odd function. And what we are looking for specifically, when we put that negative x into this function, we are looking for a sign change in every single term. So, just like before, we're going to make sure that we use parentheses when we are substituting this negative x. And we are going to pay attention to those exponents. In the previous example, we talked about that when you raise something to a even power, it is going to make that term positive. When you raise something to an odd power, the term will remain exactly the same. So this negative x will remain negative. When I clean up this first term, I will get negative 2x cubed. When I multiply negative 4 times negative x, I do get positive 4x. So here's what I'm looking for. This new function that I have created, is it exactly the opposite? Every sign changed in every term. And it is. So this is an example of an odd function. Now in this last example, we're supposed to state whether or not this function is even, odd, or neither. First question I would ask myself is, can I fold it on the y-axis and everything on the right match up with everything on the left? And the answer is no. So the question I would ask next is, could I, rotate it rotationally around the origin? Look at those diagonals. Does this point match up to this one? And the answer is no. So since it doesn't fit into either one of those categories, this function would be considered neither. Again, to demonstrate this algebraically, we're going to use exactly the same method. We are still going to substitute a negative x everywhere that we see x in our problem, and we're going to make sure and use parentheses as we do this substitution. And like I had said before, if you are raising something to an even power, it is going to make that term positive. But if you're raising it to an odd power, it's going to remain the same. So in this first term, this is going to remain negative. The number on the outside is positive. So when I multiply these together, I do get negative 2x cubed. In the second term, because I am squaring this negative x, it is going to become positive. And when I multiply it times negative 3, this term will be negative 3x squared. On the next term, negative 4 times negative x is positive 4x. And then this final term, I don't have to do anything to it, so I'll just write it down. So now when we compare our new function to the original function, we see that the first term did change signs, but the second did not. That right there I can stop on, because either the new function will be identical to the original, or every single term will change signs. And since neither one of those things happened, this is an example of a function that is neither odd nor even.